Late in 1982, the global scientific community realized their weather models were failing. A massive climate anomaly was well underway, but researchers lacking real-time data didn't even detect the shift until it was nearly at its peak. The sheer scale of the event caught forecasters entirely off guard. In the arid regions of northern Peru, riverbeds that were usually bone dry suddenly swelled to 1,000 times their normal volume, carrying away topsoil, infrastructure, and livelihoods in a matter of hours. This was a super El Niño, and while the 1982 event forced scientists to build new planetary observation systems, it leaves us with an urgent question today. What happens when an event of this magnitude strikes a modern world that is much hotter and vastly more fragile? These events act as systemic shockwaves, testing the physical and economic limits of human civilization. This satellite map illustrates the threshold of a super El Niño. When sea surface temperatures in the central and eastern Pacific rise more than 2 degrees Celsius above their historical average, you see this massive red and purple heat anomaly stretch straight across the ocean. That concentrated heat doesn't stay in the water. It alters the atmosphere through a mechanism called climate teleconnections. Think of these as invisible threads of atmospheric energy snapping outward from the Pacific, forcing simultaneous weather shifts thousands of miles away. Today, those threads are striking a global baseline that is already stretched. We are operating with severe fertilizer shortages, ongoing geopolitical conflicts, and shipping lanes that frequently bottleneck. A modern super El Niño acts as a threat multiplier. It takes these isolated local points of stress and synchronizes them into a global breakdown. To see how that breakdown starts, we look beneath the surface. This diagram maps upper ocean heat anomalies down to a depth of 300 meters. The downward diagonal lines represent Kelvin waves, massive pulses of underwater heat physically traveling across the Pacific over months. When that immense volume of oceanic heat finally surfaces, it forcefully alters the trajectory of the atmospheric jet stream, effectively moving the massive wind currents that guide the planet's storm systems. The immediate results are heavily polarized. The vital summer monsoon rains that hundreds of millions of people rely on in India and Southeast Asia weaken and fail. At the exact same time, the southern United States and parts of East Africa get hit with relentless, catastrophic floods. These atmospheric shifts rewrite the global water distribution map entirely. Historical weather patterns become useless, and the agricultural calendars that farmers have used for generations are rendered obsolete. The shock hits marine biology first. The warming waters suppress cold, nutrient-rich upwellings off the coast of South America, suffocating the world's largest fishery and decimating the Peruvian anchoveta populations that feed global livestock markets. That same marine heat wave concurrently triggers mass coral bleaching events worldwide, wiping out the foundational ecosystems that protect coastlines and harbor ocean life. On land, the lack of expected rainfall causes severe droughts. Rain-fed agricultural zones, particularly across southern Africa, watch their cereal production wither in the fields, creating a sudden, urgent need for international food imports. Simultaneously, the aggressive spike in terrestrial temperatures dries out vulnerable ecosystems like the Amazon. This triggers massive, widespread forest fires, releasing enormous amounts of stored carbon back into the atmosphere and accelerating the warming cycle. You now have failing fisheries, rapidly dying crops, and burning forests happening at once. It is a synchronized biological shock that our already weakened supply chains simply do not have the capacity to absorb. The human toll follows quickly. Stagnant floodwaters combined with extreme heat create the perfect breeding ground for mosquitoes, triggering massive regional outbreaks of vector-borne diseases like dengue and malaria, which quickly overwhelm local hospitals. On a macroeconomic scale, a super El Niño acts as a massive negative supply shock. It contracts economic growth while driving inflation sky high. In Peru, aggregate GDP steadily drops, hitting a trough nearly 5% below its pre-shock level by the second year. This puts central banks in a nearly impossible position. To fight the sudden spike in inflation, they are forced to hike interest rates. But raising rates during a massive agricultural and economic contraction only stifles recovery and makes credit harder to access for struggling communities. This weather anomaly leaves behind a destabilized global economy, where traditional monetary tools fail to protect human livelihoods. Economists refer to the breakdown of this relationship between inflation and economic activity as the end of the divine coincidence. It reveals that modern economic structures and central banks are unequipped to fix persistent, climate-driven supply shocks. But there is a distinct advantage to an El Niño. It builds slowly in the ocean over several months. Forecasters can track the rising temperatures and provide advance warning, giving governments a brief, critical window to take anticipatory action. In practice, this means deploying physical infrastructure adaptations ahead of the storms. Communities can reinforce flood protections and construct decentralized water capture systems, like these hillside trenches, to bank rainfall before the inevitable droughts follow. Agriculturally, authorities can use the warming months to distribute short-cycle and drought-resilient seeds to vulnerable farming communities, ensuring a harvest even when the seasonal rains fail. Surviving the coming decades requires a different approach. We have to stop treating these climate shocks as unpredictable emergencies and start managing them as forecasted systemic risks. A super El Niño serves as a planetary stress test, proving that the human infrastructure we rely on, our borders, our markets, and our hospitals, is entirely at the mercy of interconnected atmospheric forces. Preparing for the next inevitable event requires a holistic global vision. Isolated local planning falls apart when climate teleconnections ensure that a warming ocean thousands of miles away can empty your local grocery store shelves. Look closely at your own local supply chains. How resilient are they to a shock originating halfway across the globe? If you want to understand the invisible forces shaping our economy and our planet, hit subscribe, and we'll see you in the next video.
Reality is weird.